Hello everyone. Welcome to this new topic on Python programming series. In this, we are going to learn about functions, how we are going to implement user-defined functions in Python. And my name is Said Usman Ahmed, and we are going to learn this through some programming examples as well. We won't be doing coding actually on this, but we will be showing you some programs and through which we will explain you the complete concept of functions that we use in Python programming. So let's begin uh, the, the presentation now. Okay. By definition, what is a function? What is a function? Let us understand what is a function. Function generally is a function is uh, a code, or what you can say, a function is are the most basic program structures in Python that is used for code reuse or minimizing code redundancy. Okay, so if you want to see what is code reuse, that means that if I write a piece of code here, I write a code here, right? And this code is for, suppose, calculating the sum of two variables, say a comma b, right? And what it does, it will take two variables a and b, and it will give you the sum of both the variables, right? This is my code. So what it will do, somebody else, this is myself which I am doing this here, right? This is the thing I have written it, but somebody else also need that sum. He is also thinking about writing the function for sum, right, with some other parameter called c and d, suppose. So what he can do, either he can create his own function, or he might use my function by passing these parameters. Instead of a and b, he can pass c and d, and the result will be the sum of c and d instead of a and b. Now he can be using the same code with different parameters, right? So this is known as code reuse. And secondly is, it also minimizes the code redundancy. That means writing the same piece of code and again. Suppose in my complete structure with a program, suppose that I have a complete program and I want to define sum here, right? I want to define sum here, and I again want to define sum here, right? So instead of writing the definition of sum every time, right, what I can do, I can write sum once and call this sum again and again n number of times. Okay, so every time when I call sum, this function will be jump to the definition. It will execute whatever is written here and come back whenever this function is been called. So suppose the next time I called here from this part, then it will again jump to the definition, execute it completely, and then come back to my original. So the thing is, writing something again and is called for redundancy. So it will minimize the code redundancy part as well. So it will maximize the code reuse and minimize the code redundancy. In simple terms, a function is a block of code that groups a set of statements so they can be run more than once in a program. In this, what we actually understand is, functions on in the other hand is just a set of that particular part, that particular system, which actually creates we group certain set of statements together, right? We generally arrange them in that fashion that can be run more than once in a program. So we can say that a function is a set of statements that we have seen there, right? So we have seen this here, that if we want to write this a function called sum, right? So what we do, we write here, we write it as sum, right? And we write it as sum. We write it as sum here, and then we execute this code here. This is a set of statements. Now these statements, what do? There is a common goal. The common goal is to sum variables. The common goal is to write the sum of the variables, right? This is the common goal for this particular code, right? So this code has one goal, that is to sum a particular two values. So I will take two values a and b and I will do summation. Okay, this is the complete goal of this function, right? So that's when I will say I will read two values, I will use a logic of summation, and I will then print the value of the sum. So these are the four basic statements that should be part of the block of code, which is called as sum. Likewise, I can create more functions which can actually help me to do certain set of statements. Okay, now what are the different components that are part of the sum definition? So we actually create a function like this. We will actually use a structure like this for defining the function, right? And the body of the function. So we start with the first thing, that is called the definition. So we use a keyword called def for defining a function. So this keyword has to be present when you want to create a function, right? You want to write the definition of a function. So we use the keyword called def for defining, for specifying that we are starting the definition of a function. Next thing is the function name. The function name is a user defined function name like sum or average or palindrome or factorial. You can give any name to this function, right? Then followed by parenthesis, and in the parenthesis you are having the parameters. Parameters are the values that are passed by the function call. Okay, we will see the type of parameters in the following slide, but as of now you understand that after the function name we can pass certain parameters. Might be possible you don't pass any parameters even though you will be using parentheses, right? The function name is followed by set of parentheses. Inside the parentheses, if you pass certain values, they are known as the parameters. If you don't pass any values, it is without a parameter, a function call. Now another thing is, every time you write a function you have to use these colon. Okay, you have to use this colon marks, right? These marks you need to use it. If you don't use, you won't find the proper indentation that you can see, which is very much required in Python. So you need to have the colon marks. Once you do with the colon marks, then only this function actually works in a proper way. The next thing is called the function body. The function body is a set of statements or the instructions that this function implements. Then whatever this function actually do, we will write in a form of function body. And finally, you have an expression or a variable or a value that a function returns. So if a function actually returns something, then only you will use return expression. If it is not returning any value, then you can omit this particular value. So in short, what we can say is this return value is optional. Okay, this is optional. What do you mean by optional? Optional means if you don't write this return return statement, the function is not, it is not that the function will not run. If the function body is such that it returns a particular value, then only you will use this keyword as return, right? You will use the keyword that is known as return, and if you have return, you have to have an expression, otherwise you don't have an expression. So all these things actually are the basics of how you define a function. Okay, now we will see certain specific syntax also, that we will define a particular function, and then we will tell you what are the parameters, how we actually call a body of a function, and then how we call it in a return form or without return form as well. So now the benefits of using a function is we can use the same function multiple times in our program, which makes the code reusable, and functions help us to break our code into chunks to make our program readable and easy to understand. Okay. Now there are two types of functions that we actually use. One are called the standard library functions that the Python give us, like print. Like you have function for print, right? You have used this function. It also has a parenthesis in between. You can write certain statements, right? You have a function called input, right? You have seen these functions. So these functions are called standard library functions, or they are functions that Python has provided us. And on the other hand, there are certain functions that we create for own self, like we want to create a function called fact, right? We want to create a function called sum. We want to create a function called, say, palindrome. Okay, so these functions are not built-in functions, so we need to have custom defined or a user defined functions. So what we will do, the problem here is, because these functions are not defined by the Python interpreter, or they are not recognized by the Python interpreter, we need to provide a mechanism where we can actually define and then we call them. This is how we happen. This is happened. The thing is, the first step is to define the function. Okay, first thing is you define the function, and the second thing is you call the function. Because if you don't define it, the interpreter won't interpret it and it will throw an error. So if we don't define it, the interpreter will throw an error and it will not recognize that particular thing as a function call. Now the next thing is the formal syntax of a definition. So if I say this def abc and I pass x1, x2, x3 up to xn some values, then def this particular, and I have a function body and return z is the statement. So this the thing shown here is called as a function body of abc, right? So I am writing a function. This is called definition of the abc. You have to define that. So this thing is actually, what it is doing here is, this thing is actually defining. It is defining abc, the function abc, right? And this thing, now the second thing is the call. The abc with 1, 2, 3 up to 10 is the actual call of that function abc in the program. Now there are two type of parameters. One is called the actual parameters and one is called the formal parameters. Actual parameters are the actual values that you are passing in the function abc, and formal parameters are the parameters that don't have any value but they are formally related to abc. When I will be using these parameters, what it will be doing is, it will be matching the parameter counts as well as the data types, right? So what it will do, it will check whether this thing, it will map x1 to 1, right? It will map 2 to x2, and it will map 3 to x3, and it will map 10 to xn. Okay, so if you have more than 10 values here, right, what will happen, you need to check. If you don't have 10 values and you have 10 parameters defined, what will happen, you have to check. So in both the cases it will throw an error. So to understand that, you should know what are formal parameters. They are the parameters that are used in the definition of a function. And what are actual parameters? There are the parameters that are actually you pass when you do a function call. So once you have defined a function, then only you can call that function. Until unless you define the function, you cannot call the function. The system will throw an error. So let us see one example, a very simple example that reads two variables and print the sum using function, right? So what we do here is we define a keyword. We use a keyword called def, right? The def keyword is followed by the function name called sum, and it has two variables, two parameters, a caller followed by b, right? Now this function says when this function will execute, so I will give the function name and I will define this function, what this function will do. So what I will do, I have chosen a variable called c, and what c is doing, it's having the sum of a plus b. So I will sum this a plus b and the sum is transferred to c. Once I get c, I can print sum of, this is the string, followed by the value called a, then a string called and, then a value called b, and then a string called is, and then finally I have C, because C has been computed as a plus b, so this thing will be printed. Okay, now this is the definition. I'm ready with the definition. Now what I need to do, I need to do a function call. But before function call, I should know what are a and b. So I actually take these two values from the user, saying what is the value of a. Okay, I have taken this from the user, the value called a, this is the value called a, and this is the value called b, right? So I have taken the value of a and b, and I use the now the same name as sum, right? Pass the parameter a and b into this, and when I pass this value, what will happen here is, when I pass this value, what will happen here is, whenever I use this name will jump to this definition, right? And it will actually execute this particular set of statements. And finally what will happen, this thing will, because this function itself is printing it, so this function, when it prints, it stops, it come back, and there is no more statement after this, the system will stop, right? So what will happen, this is a definition, so it will execute at the start, the system will start executing from this point, this thing will execute if the system actually knows what is the this is the definition of a function named sum, so it stores the definition, right? Now it reads two values, so I have entered 3 and 2 as a variable of a and b, and then I call this sum. The sum will jump to this location, it will compute c, that is 3 plus 2, that is 5, then the system will print sum of 3 and 2 is 5. So this is how normal function works. That means it will be calling a function, so you should have a definition followed by the function call. This is the first thing. Second thing is, when you had a return statement, so we can also do something like this. We can define a function call here, function here, in which we are defining a sum, and we are defining two variables a and b. Now what we do, we sum up a plus b and transfer this value to c, right? And then instead of printing it, what we do, we set return value of c. Now what does return do? Return will be sending the data back to the function call. Okay, first of all, this is a definition, so system will actually execute this definition and store it into the memory. Okay, it will do nothing because there are no values as of now, so store it. And second thing, it start reading the value of a and reading the value of b. So they read the value of a is 3 and value of b as 4. Now what it happens, it will come to this line. This line has two parts. This is the equation now. So this is an expression. Expression says call this function sum with the value a and b. So at this point, what will have, the system will jump to this location with the actual parameters. It's represented by value called 3, which is an actual parameter called 3, and 4, right? 3 and 4. Now it will be going into it will be calling this function now with actual parameter 3 and 4. So this will be 3 and this will be 4. Okay, now this will be 3 plus 4, that is, this will be 7, and c will be 7. So it will return the value called 7. So at the time when it returns it, this complete system will be replaced by a value called 7. Okay, because this complete definition is returning a value called 7. This complete sum a b will be replaced by a common value called 7. Okay, so this statement becomes result is equal to 7. So you are assigning a value 7 to a variable called result. Okay, now when you have a value called result, you can print outside this function, right? In the main program, you are printing sum of a and b is result. Sum of a was 3, b was 4, is result is 7. So this thing is printed again as sum of a plus b is 7. But this time what we don't print that value inside the function definition. We are printing it with the help of return statement in the main function call, in the main program. So this is how we implement a function using a return statement. Now Python or a function actually has a special case which is known as recursion. Okay, recursion means when a process is calling itself again and again, right? In Python, we know that the function can call other functions. We have seen this was a main function, and the main function was calling another function, right? Another function, but it can happen that the main function can call itself again and again. So if I have a main function, and I'm calling that function again and again. So I have a function called sum. And I'm calling this function again and again. So it can be, it looks like it goes into an infinite loop, right? It goes into an infinite loop. So because I'm calling the same function again and again. But the best thing in recursion is in loop, we have seen that in loop that there are two conditions in loop. That is, you repeat the statement again and again, and second thing is you are coming closer and closer to a final value. So you're converging to a final value where the loop should end. Likewise, in recursion, whenever you call this sum, or when you call this function, called any function which calls itself, it is coming closer and closer to a value which is known as base value. Okay, and this is the value, is a value at which this recursion should stop. So a recursive function, as it calls itself, recursion ends if the base condition is satisfied. So if you have a base condition, then whenever this base condition gets satisfied, the recursion should stop, right? Every recursive function must have a base condition that stops the recursion, or else the function will call itself infinitely. So you need to have a proper base condition. If you don't have a base condition, then your system will go into a infinite loop of condition, right? So let us understand that recursion with the help of a simple program. So this is a program of calculating a factorial of a number, right? And I have first of all, what I do, I define this function. I define this function. So I have used a name called factorial, and I have passed a variable called x, right? Now what it says, suppose, let me write it here. So what I am doing here is I'm reading a number, int input, enter the number to calculate the factorial. So this thing will be printed as it is on the shell, or on the console, where it means that I need to enter the value of a number that for which I need to calculate the factorial. Suppose I enter a value called 3, right? Now what is happening here is now whenever I have 3, so I will go and next line is to print. So it says the factorial of this is written here, right? Num we have read it here, so 3 is also printed here, right? Is also printed here. Okay, so this thing is ready to be printed, but the last thing says call this factorial num. Right now I am having call, until unless I know the value of the factorial 3, I cannot print 6. Okay, so we are waiting now. So let us see what will happen. So if I generally use fact word, okay, fact 3, this is what I need to calculate because I have num 3. So fact 3, so it will go up here. So this is fact 3. Okay, this is called fact 3. It's calling this is the function fact 3. It goes inside, say x is equal to 1. So this condition becomes false. The system will go to else part. It says now it has two things. It has 3, x is 3 multiplied by fact of what? X minus 1, that is 3 minus 1. And now this 3 minus 1 is 2. So now there is another set of problem which says that fact 2 should be known. I don't know fact 2. So at this part, this function will call itself now, right? This function will call itself now. But what changes you see? It now, earlier it was calling with 3, now it's calling with 2, right? So and this point again, if I go into fact 2, again I will check x is equal to 1. No, come back to the else part. Next part says 2 multiplied by fact of 2 minus 1, that is 1, right? Again this is a fact 1. I don't know the value of fact 1. So again I will call fact x again with the parameter called 1. I come back here, I say x is equal to 1. Okay, I will do x is equal to 1. That means that let me see whether I can change the ink color. Okay, I can change it. Let me change it. Okay, so the thing is, when I see this x is equal to 1, in this case I know that the return statement is 1, right? So now this function fact1 will return the value called 1. So 2 into 1, the value becomes 2, right? Now this 2 is representing fact2, so that means this fact2 is now returning 2, right? Now when fact2 returns 2, 3 into 2 is 6, fact3 should return 6, right? So this is the value of fact3. So when I know the value of fact3, I can print value called 6. Okay, so this is how actually recursion works. Recursion is calling this function again and again until and unless you have a base condition. At the base condition you stop and you then come back one by one solving the problem, right? This is how actually the function actually works with the help of recursion. So I hope we are clear with what are functions, how we define a function, how we call parameters in a function, what are actual parameters, what are formal parameters, and we also know how we actually implement recursion. So thank you very much for watching this video, and hope that you understand this. And in case you have any issues, you can just comment it out on the video, or you can reach to us in some way. I hope if you like, please share this video with others, students as well, and the fact in your community, so that other people can also understand what are functions. Thank you very much.